Good afternoon to all. Am I audible? Good afternoon to all.
Yes, sir.
So good afternoon to all. I want the more response. Good afternoon to all.
Good afternoon, sir.
So extremely sorry, I am not able to take any class last 2.5 months. I just calculate 2.5 months I am not able to take the class due to placement. Due to placement, I am not able to take any class. So already first semester is passed. So and you are already doing, just a second. Okay, you are performing in the first same is not much good. So I already share with you some video lecture is related the DFT. So today I am talking about the DSP, digital signal processing. The unfortunate, I'm not taken the class or you are not seeing properly the video also. So let's start with so here section A and B, both the student are there, no? Yeah. So today I will start with the starting from the DFT again. So most probably I will I was taken some classes of section A, but I am not taken any class from section B. So anyone response from A and B? Anyone? Anyone attend my class in, related with the DSP in section A? So what about the classes I am taken? What the topic I covered? Anyone? I talking about the twiddle factor also, no?
Yes, sir.
Yeah. Okay. So what about the section B? Anyone response from section B? Introduction to DSP. Okay. So today I just recap the DFT. I just going. I'm not discuss the introduction again. So today I am discussing starting from the DFT directly. Directly DFT. So you are familiar with some concept of discrete time Fourier transform. Please response, isn't it? And free fill to works, because I already share my video lecture also. So whatever I taken, so you know the concept of DTFT, discrete time Fourier transform. So from discrete time Fourier transform, here we consider DFT, isn't it? So let's start. My screen is visible now.
Yes.
Yeah.
Yes.
So if consider finite duration sequences xn of length L xn equals to 0. This is the equation 1. So it's coming from DTFT. Remember the DTFT formula. In that time, the duration sequence is not fixed with the L. So here we consider the fixed length of L, where n lies between 0 and L. Then xn is, I already write also in previous line, infinite duration sequences of L. Then the Fourier transform of equation 1. Anyone guess what about the Fourier transform of equation 1 for the finite length? So in DTFT we are working with the infinite. So here the finite length. If we are considering finite length, then the Fourier transform of equation 1 L minus 1, because it's starting from 0. So the notation is in this way to write that x omega equals to summation n equals to 0 to L minus 1. Then what I am written? Yeah, e to the power minus j omega n, isn't it? And omega lie between 0 to 2 pi, isn't it? So this is, we are considering equation 2. Anyone have doubt? Because this is very simple. So previously we are done infinite, now we are consider a finite length of L, which is basically 0 to L minus 1. Here we consider after the Fourier transform. Up to this, anyone having any doubt, please tell me if you have anyone doubt. I want some other student response, please. Those are responding. Okay, those are responding. So I thought they are attend the class, my class. And another thing, so before I just give you the exam link. I just give you posted in your chat box. You just check in the chat box. Share the today link. So the exam link may be most probably activated from 3:20 to 4. So in between you just give the exam. So if you are not attend the exam, your attendance is not calculated. So be very careful. You just check your chat box and give your exam in between. Okay. So after this, we don't have any issue. Now I just asking two question. So this is capital X omega. This is capital X omega. So what type of signal here we consider? Anyone guess? What type of signal we are consider? Frequency domain signal. So what type of frequency domain signal we are considering here? What type of frequency domain signal here we consider?
Continuous.
Absolutely, this is continuous. So here we consider basically continuous in frequency domain signal. And what about this one? Exactly, this is the discrete time signal. Discrete in time domain signal. Good. So this
DFT means the
dis
signal will be
discrete time. So
but in frequency domain,
just a second. Yeah. DTFT. What is the full form of DTFT? Discrete time signal টাকে Fourier transform করছি, isn't it? Discrete time Fourier transform. But there is a no limit. So we are considering n infinity to minus infinity, you know that, isn't it? But when we are considering finite length, so now, okay, so now we are doing the Fourier transform in the finite length. So up to this, hopefully there is a no questions at all, isn't it? Now I am give you some interesting part. This is very important. You must remember this part, isn't it? So as per the equation, we found two types of signal. One is the time domain, another is the frequency domain. So again, so here we are considering the notation. This is very important. Be very careful, isn't it? Here again we subdivided the time domain and frequency domain signal. Two types. What is that? One is the continuous, another is the exactly discrete, isn't it? So when we are considering time domain signal, we are written the function of x function of t, xt we are written. When the signal consider a discrete time domain signal, that time we write x of n, isn't it? And you already know about the n. What is that? What is the meaning of this n? Is basically time index. Time index means, suppose you are familiar with the DSP lab, and where you are considering a sinusoidal signal, and that sinusoidal having some lines. This line is called sample. Exactly. Here we are considering this is n, which is basically time index, and another part is there. So in this one is the in between two sample, we call this is sampling frequency. And what about this signal? This curve, this is this part is basically signal. This is signal frequency, isn't it? So you know this, familiar with this graph also. And what about the notation if we consider the frequency domain? So here you found that, and one is the x, capital X omega. Capital X omega means what? So capital X omega means frequency domain continuous signal. Whenever you write capital X omega, that means this is your frequency domain continuous. And anyone guess what about the frequency domain discrete type signal? What about the notation of frequency domain discrete type signal? Exactly. Capital XK. Capital XK. Clear? So any doubt about the notation? Any doubt about the notation? Clear. So in case of DTFT, DTFT is relation. There is a relation with the DFT. But what about the DTFT? What we are doing? This discrete time signal, after DTFT we got frequency domain continuous signal. So this will be performed after DTFT. Are you agree with me? Yes or no? Clear. Now we are coming to the our major point. We are coming to the our major point, that is DFT. So let's see. Yes, sir. So now we are coming to the our major point, that is DFT. Now what we are doing, we remember this formula, whatever we get from here. So you already see that we taken reference from this equation 2. This is very important for us. Capital X omega equals to summation n 0 to L minus 1 x n e to the power minus j omega n. Now we are going for move for the DFT. So now we just sample at omega k in term of 2 pi k by capital N, whether k equals to 0, 1, 2, 3 up to n minus 1, isn't it? So can I write down this one? We have sampled the omega k 2 pi by kn. Can I write this part? We just sampling it. Omega k is the signal. This is the phase part, which is varies from 0 to 2 pi. 0 to 2 pi. We just sample it in term of 2 pi kn. We are sampling with the term of 2 pi kn, isn't it? So if we apply in place of omega 2 pi kn, omega k in 2 pi kn, so can we modify the formula in this way? Capital Xk, can we write this one? Please tell me. Can we write down this one? Capital Xk equals to x of 2 pi kn. Yes. Now again we modified. N equals to 0 to L minus 1. This part you know. Then we write xn. Now we write or we modified e to the power minus j 2 pi kn by capital N. Can we write?
Yes.
Yeah, because in the previous case you found this part we write e to the power minus j 2 pi omega.
No, sir, it will be j omega.
E to the power j omega. So in place of omega, we sample it 2 pi k by n. We just sample it by 2 pi k by 2 pi k by n. Clear?
Yes.
Okay. So this is here you found, here you can see that formula we can write again. Capital Xk equals to summation n equals to 0 to L minus 1 xn e to the power minus j 2 pi k into n by capital N. This is equation 3. Is it okay?
Yes, sir.
So in case of DFT, what we are written? We are normally written that N point DFT formula. So what about the N point DFT formula? Again, we little bit of modified in this equation. That part is capital XK equals to summation N equals to 0 to, so previously we are considering L point because N vary from 0 to L minus 1. Now we are written in place of L, N. Is that clear?
Yes, sir.
Yes.
Xn u to the power minus j 2 pi kn by capital N. So this is equation 4, and here we are considering k from 0, 1, 2 up to n minus 1. And this is the formula of DFT. This is the formula of DFT, or we can say N point DFT. Clear? So from where to where we are coming through the formula. So we are coming from here. You just see. So we are considering a finite length duration of the sequence, that is xn equals to 0. Then we just Fourier transform, and after the Fourier transform we get x omega equals to summation n equals to L minus 1 xn e to the power minus j omega, isn't it? And after that we just sample it. We just sample it to 2 pi by n, 2 pi k by n. And after the sampling, what we are doing, we just put the value in place of omega 2 pi k by n. Is that clear?
Yes, sir.
And then finally we in place of L, finally we write down n for n point DFT, n, and this is the final equation of the DFT formula. This is the final equation of the DFT formula. So what actually we found, so you can see here in case of DTFT, what we are getting from, we are using discrete time domain signal to continuous frequency domain signal. Now in DFT case, what we are found here, time signal to, is that clear guys? Anyone having any doubt? So DTFT case of infinite. In case of DFT, finite length. This is the main difference between DTFT and DFT. Anyone having doubt? Any? Please respond, guys. If you have any doubt, please tell me. Is that clear? Okay. So now we are moving something else. So we are now knowing that DFT. So whenever you do some process, definitely this is the mathematics, definitely there is a process to reverse. There is a process of reverse is there, isn't it? So reverse means we call inverse DFT, inverse discrete Fourier transform. Now we are written directly from here to IDFT formula. So now we are, what we are written, we are using red color. Just a second. So now we are written in point IDFT. formula. So today I just take the recapitulation. Next week I will take the next rest of the part of the DFT. So anyone guess what I am written from here, from DFT formula and IDFT formula? What we are expected the output? So inverse means what I am written in the left side. Exactly. So we are finding the time domain signal, time domain, discrete type time domain signal, isn't it?
Yes.
So what about the what about the next we are written? Yeah, 1 by n summation. Okay, so let's see. Just hold on. Here we are considering xk, capital Xk, and what we are written here? N are associated with time domain signal. So now exactly. So here we are written k equals to 0 to capital N minus 1. Then what we are written expected? Capital Xk, exactly. Then e to the power, in place of DFT, what we are written? E to the power minus j 2 pi k n by n, isn't it? Here we are using plus sign. E to the power j 2 pi n into k by capital N. So whether n equals to 0, 1, 2 up to n minus 1. Is that clear? Anyone having any doubt? Hopefully no doubt at all, isn't it? So now we just move to the next part. Indu
Sir,
C.
here it will be small n equal to or capital or k equals.
Which one? Which one? Tell me.
And the inverse DFT formula is it will be k equal to 0, 1, 2 dot dot n minus.
No. This time this is n equals to not k. So when we are considering DFT, that time we are considering, because this part again depend on what? Depend on this one. So what about the result of x0? What about the result of x1? So everything depend on n minus 1. Is that clear? So here I am written n equals to 0, 1, 2. You are asking this part, no?
Yes, sir. That means this n equal to 0, 1, 2 dot dot capital N minus n, y it will be small n. It should be k.
It should be k.
K because
No, this part, when we are written n equals to 0, 1, 2, this part actually depend on this. Because what about your output result? Output result is time domain discrete type signal. Output result is in IDFT case. So the what are the point is we founding? What are the point we are actually found? Or find, sorry, what are the point we actually find? So we find from x0, x1, x2 is depend on x up to depend on x n minus 1. So that's why I am written here n equals to 0 to 1. In case of DFT, we found that capital X0, capital X1 is up to capital X n minus 1. So that's why I am written, isn't it?
yes.
Okay. Thank you. So now we found another part, important part here we discuss. This is also very interesting. So in the DFT, I just taken the DFT formula first. So I request you everyone, please attend the exam, which already exam code will already was shared in your chat box. So please give your exam, otherwise your attendance is not considered, isn't it? So here the formula of DFT n equals to 0, capital N minus 1 x n e to the power minus j 2 pi k into n by capital N. Got it? So anyone guess? Anyone guess? This part is called in the formula. What about the meaning of xn and what about the meaning of e to the power minus j 2 pi k n by n? Anyone? No, no.
Sir, amplitude and phase.
Amplitude or magnitude?
Sorry, sir, magnitude.
This is magnitude and this is your phase. This is very important. So after the DFT and IDFT formula, we are moving to this phase and magnitude part. We are calculating with the phase and magnitude part. So now the question is, there is another part is there, e to the power minus j 2 pi k into n by capital N. Is okay? Now, what about the meaning of, just use a different color. Two pi by n, or we can write here 2 pi by n. 2 pi by n means, what is that?
It is omega.
Is it omega?
No, sir.
This is called basic interval. Okay, is that clear?
Yes, sir.
This is basic interval. And what about kn? Anyone guess? What about the kn? I have already shared the video lecture. Please follow this lecture part. Please follow, is available in my Google Classroom. Please follow. I request everyone. So this is basically time span. This is actually time span. Is that clear?
Yes, sir.
So in the phase part, we have two separate things are there. One is the time span, another is the basic interval. Please remember. Okay, so we just move to the next part that is very interesting. We almost today cover half of the, almost not a half, 1/3 of your syllabus. Next we write down modified formula of DFT. Modified formula of DFT. So you know the DFT formula. So what I am written? Capital XK summation n equals to 0 to n minus 1 xn. Then we write down W A N K into N. Isn't it? Where Wn means e to the power minus j 2 pi by n, capital N, which is called twiddle factor. Good, isn't it? And this omega n also called, just remember the term, why we call, just discuss. This is periodic phase rotation factor. What I am telling? Periodic phase rotation factor. Remember the point, what I am telling. So now we are concentrated on the phase part only. So two separate part in the DFT formula. First part we call magnitude, second part we call phase. We are now talking about the phase part. Twiddle factor means this part is phase. So phase, we are separated the phase part in two ways. So first part is called basic interval and second part is called time span. Is that clear, guys? Anyone having doubt? Anyone having doubt? I want another 2-3 people, please
No,
respond.
sir, not
Okay. Now, we just take for example of 4-point DFT in phase, isn't it? We just try to find out. So 4-point means what?
Capital N equal to
Exactly, capital N equals to 4. Great. Capital N equals to 4. So capital N equals to 4 means the phase W4, isn't it? So that varies from, so N varies from 0 to
0 to 3.
N minus 1 means 0 to 3. Good. So that means W vary from W04 to W. Is that clear, guys? Anyone having any doubt? I want the others people, please respond. Okay, great. And you already know e to the power minus j omega means, if we are j pi, sorry, not omega, j theta means, you know, in term of cos and sine, we can write down cos theta minus j sine theta. Great. So now what we are written here, W04 means cos theta, cos 0 minus j sine 0. So cos 0 is 1 and j sine 0 is 0. That means the value is 1. Okay. So what about W14? Sorry, 14. That means cos pi by 2, exactly, j sine pi by 2 means 0 minus j into 1. That means the result is minus j. Then we find out W24. This is cos pi minus j sine pi. Anyone having any doubt, please respond, guys. Anyone having any doubt? If you have any doubt, so cos pi means minus 1 minus j of sine pi means 0. So that means the result is minus 1. Good. So another point is W34. Now you understand why I am written n equals to 1, 2, 3 up to n minus 1. k equals to 0, 1, 2, 3, n minus 1. Now you have clear, no? So now we write on the this W34 means W means such a cos 3 pi by 2 minus j sine 3 pi by 2. So what is that? 0 into, sorry, 0 minus j into minus 1. That means plus j, only j. So we have already found the 4 point, that is 1 minus j minus 1 and j. Is that clear? So as per the question, 4-point DFT value is 1 minus j minus 1 j. Clear, guys? Now, previously I told you that a few minutes back, this point, this is basically periodic phase rotation factor. Periodic phase rotation factor. Why we call this a rotation factor? Periodic phase rotation factor, why we call? So before that, I just try to find out another value, W44. Anyone please find out quickly? W44 means cos minus sine 2 pi. What is that the value? So 1 minus j into 0, that is 1. Is that clear?
So it is rotating.
So let's see. You know the rotating, but let's see. Just check. So I just draw a circle and two axes we are considering. So this axis we actually call real, and this axis we call imaginary. ठीक है? ठीक है? And I already mentioned and not mention one part. You just note it down. This is very important point. I just forget to tell you that this is noted point, very important. This is noted point, very important. If negative symbol present in face part. Face part means, you know, DFT formula. As per DFT formula, we write e to the power minus j. So this is the negative part in the face. Then system calculation made by clockwise. Is that clear? What I am telling, that what I am written here, if negative symbol present in face part, then system calculation made by clockwise. Clear, guys? So what is that? So now we just draw the figure, and this is on the figure. This point we are considering, this is W04. So we are finding DFT value. We are finding DFT value, isn't it? So DFT value means clockwise. Negative sign is there. So this part is W14. This is W24. And this is W34. And what about the position of W44? Exactly, W44. And what about the value of W04? 1. W44 value also 1. And W14 is minus j. W24 minus 1. W34 j. Is that clear? That part is the imaginary part, imaginary axis having a plus and minus sign. And in the real part also plus and minus sign is there. Is that clear? So That is the reason we say this is periodic phase rotation factor. Anyone, any doubt up to this? Anyone having any doubt? So that means this angle is should be 90 degree in case. Anyone having any doubt up to this? কি প্রবলেম হচ্ছে বাবা? তাহলে আর এক্সাম দেয়া গেল না, আর কি করবো? কিছু করার নেই, আমি কি করবো বলো? মানে আইদার ওই সব কেটে আবার করে বেরিয়ে তোমরা যদি করতে পারো দেখো, আর না দিতে পারলে দেবে না, আবার কি আছে, পরে দেখা যাবে। অত ভয় পেয়ে লাভ নেই। কিছু হয়েছে কি এখনো পর্যন্ত ঝামেলা অ্যাটেন্ডেন্স? এক্সাম দিতে পারছে না আইএমসি, আর কিছু কি করবো আমি? কিছু করার নেই। ঠিক আছে, মাথা ঘামাতে হবে না, আমি দেখে নেবো অ্যাটেন্ডেন্স। যদি কোনো মেসেজও যায় ওসব নিয়ে ভাবার দরকার নেই এই মুভমেন্টে, ঠিক আছে? কিছু করার নেই। So let's see another part. So up to this, anyone any doubt? Up to this, anyone having any doubt? So now I just quickly ask you just some question. I just quickly tell you some question that what about the value of W74? Quickly. Is similar value with W34. This is J. Okay. Anyone from any other person, please tell me what about the W15-4? Is equivalent of exactly. Again, I asking in other person that W35-4. Yeah. W34 again J. So that type of question you found in time of the exam, isn't it? So now let's see. I just tell you one thing. So how to calculate very quick way. W04 is equivalent of W44, equivalent of W84, equivalent of W. So in this way, isn't it? In this way, in term of 4. So always value is 1. So if you know this formula, so you can find any value. You can find any value, isn't it? So now we just quickly. So we have a 2 question for your. I just posted in your classroom. So first question you just solve yourself, that find value of 8-point DFT twiddle factor. And same another question, you just solve it yourself, 16-point DFT twiddle factor. Is that clear? So similar case of W08 is similar value with W88, similarly 16-8. So this way, this is always one. Similar way, W016 value of same is W30. Sorry, same W30. It's always 1. Clear? Now I just move to another point. I just take a 5 minutes. You have no?
Yes.
So are you feel bored? Okay. So then I just discuss with you 2 things, that is, so please don't leave. Twiddle factor properties. Twiddle factor properties. So 2 properties are there. One is the symmetrical properties. So I just take an example. What is that? The formula of the symmetrical property. So in time of the exam, you get that kind of question that you just prove the symmetrical property. So what about the symmetrical property? We write down at the formula Wk plus n by 2 n equals to value of minus Wkn. So for example, if we consider, k equals to 0 and n equals to 4, we just put the value over here. W0 plus 4 by 2, 4 equals to similar value of W04 minus of W04. So that means W24 is similar value with minus W04. So W24 means what? Minus 1. And W04 is 1. So before that minus sign is there. So this is a proof of symmetrical property. And another property I just consider here for discussion, that is properties number 2, periodicity properties. What is that the formula? That formula is Wk plus n by n equals to Wkn. Example, same example we are considering. K equals to 0, n equals to suppose 4, then W0 plus 4 by 4 equals to W04, and this is W44 equals to W04. So you already know the proof of that. W44 value is 1 and W04 also 1. This is the proof of periodicity. So today I am discuss from the beginning. Again, I just recap the things. That is, the first we are considering the DTFT formula. Basis on the DTFT formula, we are here consider the, for finite length we are finding the Fourier transform, and from the Fourier transform we get the result of omega w, that means continuous in frequency domain signal. Basis on the formula summation n equals to 0 to L minus 1 xn e to the power minus j omega n. Then we see the discussion of the different types of time domain and frequency domain signal and the notation. And then we find the formula of DFT from the DTFT in the finite length. So first we sample the omega part and that put in your DFT formula, and also we finding the endpoint DFT formula. We say in place of L we are considering n, and we finally get the DFT formula. When DFT formula we have, that means we must have the inverse DFT formula, that is IDFT, and basis on the DFT formula we also finding the IDFT formula. So in time of the exam the proof of DFT or IDFT question is not found, I just assure you. Then we see the formula structure. So in the DFT or IDFT, whatever we are considering, so first part we call the magnitude, second part we call phase, and then we are splitting the phase part in term of time span and the basic interval. After that, we modified the formula of DFT. That means we are introducing the twiddle factor, which is also called the periodic phase rotation factor. And basis on the periodic phase rotation factor or twiddle factor, we finding 4-point DFT value. 4-point means that value from starting to 0 to 3. And basis on the value, we also draw some circle and we prove why twiddle factor is called rotation phase periodic is basically periodic phase rotation factor. And we also noted that if negative symbol are present in the phase part, then the system calculation made by the clockwise, system calculation made by the clockwise in term of the twiddle factor. You just remember this part. And basis on that, we also found that for multiplication factor, in case of 4-point twiddle factor, always we got the value of 1. And I just give you 2 questions from your homework, that is you just find out 8-point and 16-point using the calculator. So I'm not here to practice this part because this is wastage of time, because I'm not taking the more class of the DFT, so that's why. So you just find out yourself and just share with me through the classroom. Then the twiddle factor properties, 2 major properties is there. One is the symmetrical. So I just give you the formula of the symmetrical properties, and then I just prove a simple take a example. And similarly, we also prove the periodicity property. Is that clear? Yeah.
Sir, here I have a question that if this proofs comes of this symmetrical property or this periodicity formula, do we have to prove using this example, right?
Yeah. So, okay, thank you for attending the class. So, I just check whether the exam having some fault or something. Again, I just posted in your group the exam link, isn't it? Posted in your group in the exam link. Not now, after 5. So, thank you for coming, guys.
Thank you.